Hello, ladies and gentlemen. Good morning, good afternoon, and good evening to everyone. Welcome to today's SMM free webinar. Today, we're going to talk about the global lithium-ion battery pattern, how it is changing under the influence of IRA policy in America. And we're going to share the following topics according to here below. First one is, how is the global lithium-ion battery look like? The background of IRA regulation or promulgation. And the second one is, what is the key of IRA and the FEOC regulations? And the third part should be, what is current status? Is the market on the right track? And today we invited our senior analyst, Mr. Thomas, and he will share the more detailed information with you all. And if you have any questions regarding today's topic, you can type your questions in our chat box and we will answer you later.
Thanks, Cassie. Hi, everyone. My name is Thomas Fong from Shanghai Metals Market. Today, I'm going to talk about the global lithium-ion battery pattern is changing under the influence of IRA policies. First, we're going to go through how is the global lithium-ion battery market look like. Overall, the global lithium-ion battery capacity reached more than 2,000 gigawatt-hour in 2023, and it is expected to maintain an annual compound growth rate of more than 28% over the next 5 years. By 2027, the global lithium-ion battery capacity is projected to exceed 6,000 gigawatt-hour. In terms of distribution, the capacity of lithium-ion batteries in Asia dominated in 2023, accounting for nearly 80% of total capacity, with China, South Korea, and Japan being the primary contributor. Furthermore, Asia's lithium-ion battery capacity is expected to continue to maintain its dominant position in the next 5 years. Meanwhile, as the two other major consumer markets for new energy vehicles and energy storage, Europe and the United States are accelerating the construction of lithium-ion battery capacity through local battery industry chain development, driven by policies such as the IRA in the United States and the new European Union battery laws in Europe. Under the rapid capacity expansion, capacity utilization rate have been declining year by year. However, from a long-term perspective, the overall excess capacity of the industry remains a structural issue. As the power and energy storage battery sector gradually mature and competition become more intense, some companies being phased out and terminate some of their planned capacities, which will eventually lead to a dynamic equilibrium of supply and demand in the battery industry. How is the current situation of the raw material supply chain as battery capacity being globalized? Let's move on to next page. First of all, the global battery material industry chain is rapidly implementing, but the regional distribution of capacity is still uneven. This is the diagram of NCM cathode production capacity distribution in 2022. The region with the deeper color map represents higher production capacity in 2022. As comparison, we also label the expected capacity in 2027 for major regions. As we can see, NCM cathode capacity distribution is similar to that of batteries, with China taking the lead, followed by Japan, South Korea. Europe and the United States is making slow but steady progress. The trend of globalization for the battery materials or battery cells, excluding the cells and NCM cathode, is obviously slow, with high industry concentration and low industry operating rate. First, unlike NCM, the proportion of LFP cathode production capacity in China massively surpassed the percentage of NCM. Also, the globalization of LFP capacity expansion is relatively slow, with massive overcapacity and high production concentration. The perfect margin for companies is extremely squeezed. Also, let's look at the anode capacity as an example, where China holds nearly 99% of global capacity, and the other regions are still having slow progress in allocation. The globalization progress for electrolyte in ex-China region is also slow due to policy approval reasons. Thirdly, let's look at the separator. The separator industry is predominantly growing in China due to the slow development of production capacity in regions outside of China. The proportion of production capacity in other countries will be declining in the future as most of the new capacity is still being established in China. Overall, the globalization of primary material is still slow, and anode material is still heavily reliant on China's supply in the nearby future. In the field of new energy chemical, the production capacity of precursors as well as nickel, cobalt, and magnesium sulfate are mainly concentrated in China. However, the raw material are still depend on various resource-rich countries. In ex-China countries and regions, PCAM and lithium hydroxide supply are currently dependent on imports from China, but their future production capacity will increase. When it comes to lithium carbonate, the supply in regions outside China is relatively abundant, whereas China is now quite dependent on other countries to a certain extent for both raw material and finished products. Similar to carbonate, the production capacity of nickel, cobalt, and magnesium is mainly in China, but the raw materials depend on other countries. Overall, the global petchem and its material supply is highly dependent on China, but China relies on other countries for nickel cobalt mineral resources. On the other hand, other countries currently need new capacity for nickel cobalt refinery conversion. The biggest advantage of new energy over traditional energy is its depth in recycling. The layout of production capacity for each recycling segment is very important for the long-term development of the industry. In the picture, we show the status of different recycling segments in 2022 for countries or regions, where major lithium-ion battery recycling arrangements are primarily located. In the recycling sector currently, China has the highest number of lithium battery recycling companies and the largest volume of battery recycling in the world. With the complete production capacity at each segment, other countries and regions may lack the process. Overall, for the battery material, uneven distribution of production capacity is the main concern. In the globalization progress of battery production, the production capacity of main material is still highly concentrated in China, causing a mismatch in regional supply and demand. And for battery chemical enterprises, high dependence on imported raw material is a big risk. Global metal refinery output are dominant in China, but the raw materials are still dependent on imports. And intense competition, restriction of local policies are also main issues for almost all battery material and chemicals. Numerous participants in the industry and rapid shrinkage of industry profit due to fierce competition, high concentration of leading enterprises, with the survival space for small and medium-sized enterprises will becoming increasingly severe. And also the local policies such as the IRA generate opportunities for overseas expansion, but also at the same time, it will pose greater obstacles to the export of maybe like Chinese battery materials. Opportunities always come from challenges. The geopolitical risk and policies related to mineral resources import and export increase the uncertainty of future metal product sales. The increasingly transparent recycling policy in China compared with the relatively well-established legislation in ex-China market both have their own advantages. The construction of new recycling capacity in various countries needs to learn from each other's strengths. Next, we're going to move to what is the key of IRA and its legislation. The IRA legislation is designed to stimulate the development of local new energy industry in the United States, with requirements gradually intensifying over time. In August 2022, the IRA, or we call it the Inflation Reduction Act, was approved. The act plans to invest $369 billion over a 10-year period in the areas of climate change and energy security. and it is widely regarded by the market as the largest investment legislation in US history, aimed at addressing climate and environmental change issues. First, let's have a look on the influence on the IRA of the EV market. One provision for consumers includes a tax credit subsidy for the purchase of new energy vehicles that meet certain requirements. With the passage of time, the requirement for the proportion of key raw material for power batteries and the value ratio of production assembly will increase year by year. With a periodic amendment such as the FEOC, or we call the Foreign Entity of Concern, interpretation document, which was just introduced on December 1 last year. Additionally, also for the solar and energy storage sector, the IRA makes significant reform to like ITC and PTC policies by adjusting their duration, eligible target, and subsidy intensity. The ITC is extended for 10 years until 2033, when the subsidy phase down will begin. The scope of tax credits has been further expanded to include standalone energy storage with the subsidy range. And the magnitude of tax credit is further increased, with up to 40% additional credit available on top of a 30% base credit. The PTC policy is also restarted, providing subsidy to electricity provider based on power generation amount, with the subsidy amount adjustable for inflation. Also, additional credits continue for domestic manufacturing and energy communities. And also another some kind of new credit like 45X, which directly credit domestic production of solar PV common, and also 45C, which subsidies investments in the construction of clean energy production equipment. Next, let's take a look at the specific production requirement for the core component in new energy vehicles, the power battery. The requirement of the IRA for power batteries are divided into two categories, key mineral raw materials and battery components. On the key mineral raw material side, the IRA speculates that the key mineral materials of lithium, cobalt, graphite, nickel, and other raw materials used in the vehicle power battery are required to be extracted, processed, or recycled in the United States or countries with effective free trade agreements with the United States, with applicable percentage increasing from 40% in 2023 to 80% in 2027 and beyond. Moreover, starting in 2025, clean vehicle eligible for tax credits must not include any key minerals that are extracted, processed, or recycled by FEOC. In terms of battery component, the IRA speculates that the value of qualified battery component for power for batteries, including active electrode materials, batteries, and battery modules, these are also mass produced or assembled in the United States, must meet a certain percentage that to be eligible for a subsidy of $375,100. And this applicable percentage requirement will increase annually from 50% in 2023 to 100% in 2029 and beyond, as we can see from the diagram. In addition, starting in 2024, clean vehicle enjoying tax credits must not contain any battery components manufactured or assembled by FEOC. In December 2023, the U.S. Department of Energy issued specific criteria for determining what is FEOC, also what is foreign entities of concern as outlined in the IRA. This is defined as foreign entities that are owned, controlled, subject to the jurisdiction or directed by the government of covered countries. The covered countries include China, Russia, North Korea, and Iran. An entity that is owned, controlled, subjected to the jurisdiction, or directed by the countries will be classified as FEOC. The criteria are detailed as follows. The first one is subject to the jurisdiction. This means that the foreign entity is incorporated or has its principal place or business with a covered nation, as we mentioned is China, Russia, North Korea, and Iran, or such a foreign entity engaged in extraction, processing, or recycling of the critical minerals, or the manufacturing or assembly of components, or processing of materials in the covered country, as we mentioned above. Or the second is owned, controlled, or subject to the direction. This means that the government of one of the four countries collectively hold, maybe indirectly or indirectly, to more than 25% of the board seats, voting rights, or equity of the entity. Let's look in the detail. The table on the left illustrates that the criteria for determining whether the overseas subsidiaries or joint venture of domestic companies will be classified as FEOC. Firstly, both the parent company belonging to the covered nation and its direct subsidiaries are considered to be FEOC. In determining whether the overseas subsidiary or joint venture qualified as FEOC, the underlying intent of this policy focuses on actual control. The 25 threshold refers not only to entity stake, but also takes in account overall control based on the combination of board seats, voting rights, or equity stake, with the highest measure prevailing. The main concern here is actual control, also determined through equity penetration. If such actual control does not exceed 25%, then it will not be defined as an FEOC. Followed by the enactment of the IRA, various enterprises involved in the lithium-ion battery supply, solar, and wind, they have chosen to hasten their strategic establishment in the United States and are planning their relevant production capacity. This potential growth of manufacturing capacity should offer more domestic battery options that could reduce exposure to trade risk and freight disruption. China enterprises have already flocked to the United States to establish relevant production capacity. The left image lists some Chinese companies' planned production capacity in the US and its free trade agreement countries. However, according to the latest FEOC regulation, it appears that only a small proportion of joint venture will meet the FEOC speculation. Taking the technological licensing model between CATL and Ford as an example, Ford has stated that it will own and operate a Michigan factory, which will allow it to government the effective control threshold as interpreted. This means that the CATL and Ford technology licensed battery plant will not be classified as an FEOC, and this model will not affect CATL's development in the US. Among other listed companies, EVE Energy holds only a 10% equity stake in its joint venture, so it's expected that it will be unaffected by the FEOC regulation. And from the current equity structure standpoint, the rest of the companies will be subjected to the constraint of FEOC. Let's take the ESS LFP battery industry chain for example. The current energy storage battery cell capacity in the United States can only meet about 6% of the demand. But with the support of the manufacturing of lithium-ion batteries, foreign lithium-ion battery companies are expanding their production in the United States. So we expected that the sustainability of supply and demand of battery will quickly increase in the nearby future. But for the cathode material, most of the existing cathode material in the United States are integrated matching LFP battery for EV, and the supply for LFP battery for energy storage is limited since it is difficult to switch between energy storage and power material. Besides that, subject to environmental protection and restriction on the phosphorus content of LFP battery, the supply in the future will increase slightly. For mining resources, although the United States has some lithium resources reserves, but due to the mining pollution restriction, the supply of domestic lithium resources in the United States is limited. So supported by the domestic manufacturing subsidies in the United States, the matching degree of US battery cell is improving year by year, while the upstream mineral resources and cathode material are limited by the local enterprise layout, which will become the main domestic supply bottleneck of the industry chain in the short and long term. In terms of cost, both the United States and Europe have higher factor cost of production. Regarding per capita labor costs, Europe direct labor costs are about 1.2 times that of China, while the United States direct labor costs are about twice that of China. In terms of indirect labor costs, both Europe and the United States have unit costs, which will lead to potential wage bargaining, and these indirect costs are about maybe 4% of wages. Therefore, after a comprehensive calculation, the per capita labor costs in the United States are about twice that of China. In terms of the number of personnel needed per unit of capacity, looking at the number of production shifts, the number of team members per shift in China is about 79% of that of the United States, and of 91% of that in Europe. Typically, Europe and the United States operate 4-shift system, while China uses a 3-shift system. As a result, after a comprehensive calculation, the per capita labor cost and the number of personnel required per unit of capacity in Europe and the United States are both higher than that in China. Higher factor cost of production also event in the treatment of air and wastewater. By estimating the requirement for air quality and water discharge indicator, the average cost of air treatment in the United States maybe is about 3 times that of China, and the cost of water treatment is twice that of China. Next, let's thought from the perspective of U.S. energy storage system integrator. We will explore the feasible method for obtaining the ITC subsidies under the IRA legislation. The first type is to choose to manufacture energy storage batteries in the United States. This kind of approach is the most competent way to obtain ITC subsidies, as the battery represents the highest proportion and the most crucial cost component of energy storage system. In this case, at least 50% to 65% of the energy storage system's costs are produced domestically in the United States, while parts of like PCS or other containers can be imported components. The second approach is to continue choosing imported battery cells and carry out integration in the United States. Before integrated or battery manufacturer in the United States increase their capacity, importing cells from pack assembly is considered a viable and temporary option. From a cost perspective, the additional cost for back assembly in the United States is relatively small, generally within the range of 15 to 20%. Although this method may add certain costs, it remains a relatively feasible solution for the American integrators. Importing cells for assembly can meet current market demand and fill the supply gap prior to the expansion of battery manufacturing. Moreover, this approach can also reduce the pressure on time and cost, as construction new battery manufacturing plants require a considerable amount of time and also high investments. However, choosing this method also means that nearly all other components, including containers and PCS, must source from the United States to cooperate with the requirement for the incentive under the IRA. The last one method may be to import containers and PCS. Integrating important containers and PCS presents a challenging approach, particularly as the IRA subsidy threshold is set to increase from a domestic production rate of 40% to 55% over the next 3 years. This requires that the overall cost of battery pack must be controlled at around nearly maybe 55%. The final section will present our forecast battery cell assembly costs in the United States and the different scenarios up to the year 2030. We have taken into account 2 production scenarios. The first scenario involves importing cathode material and the other 3 primary materials from China and assembling the battery cells in the United States. The second scenario involves importing cathode material from China, sourcing the other 3 primary materials domestically within the United States, and then assembling the battery cells here. It is apparent from the diagram that in the absence of the tariff, when considering subsidies from the battery cell assembly process in the United States, scenario 1, which involves importing all 5 primary materials from China, is the most favorable. The reason is that China has a cost advantage in the production of these raw materials. After considering the potential tariff, an overseas deployment strategy becomes the most economically advantageous in the context of tariff. With the overseas deployment scenario, the production scenario 2, where the cathodes are supplied from China and the other key materials are supplied from overseas, is the most cost-effective, avoiding tariffs on the import of materials. So that's all my speech. Thank you guys for listening.
For more questions, please feel free to reach out to our mailbox or Kathy Tai at smm.cn for more detailed information, or you can visit our website on metal.com and we will get back to you. Thank you very much. Thank you very much for attending today's free webinar, and we've got several questions here, and all the attendees can get our presentation via email within 5 working days. And the record of this webinar will also be updated on our website. Thank you very much, Federico, for the question here. Later, we will send you the presentation, and in the document, it contains our contact people's information, and you can reach out for more questions there. And for all the questions that have been typed here, we will get back to you via email to answer your questions. So thank you very much for attending.